Department of Electrical and Electronics Engineering, BSN College of Engineering and Technology. Today I am going to discuss about the issues occurred in the process control industries and what are the things needed to control the process and make the process for smooth running, and we can get the desired product at the desired quality. So my title is Issues and Need of Process Control. My content of my presentation is, I am starting with the introduction about process and process control and objective of the process control and requirement for the process control. Then I discuss about the issues occurred in the process industry, and for avoiding that issues, what are the control technique I am adopting and controlling the process, by the way of which I could find the solution for the issues. Introduction. Let me start with the process. A process in science of automatic control denotes an operation or series of operations on fluid or solid materials during which the materials are placed in more useful state. Automatic control is the maintenance of desired value of quantity or condition by measuring the existing value, comparing it to the desired value, and applying the difference to initiate action for reducing this difference. Thus, automatic control requires closed loop action and reaction operating without human aid. Next I move on to objective of the process. I mean that process control. Here I am considering one plant. For that plant I am giving the raw material as input and I can get the product. So the plant receives the raw material, then using the available sources of energy, and the plant produces the product in the most economical way. I mean that the plant receives the energy from the raw material and produces the product in the most economical way. To meet the requirements, we need to meet some requirements. Process control with requirements. The process control is essentially deciding how much the input must be changed to correct any deviation in the output from the desired value. Requirements. The first primost requirement for the process control is safety. Safety is very important one. As far as safety is concerned, we need to concentrate much on human safety, then instrument safety, then environment safety. Like that, three kind of safety people are concentrating. First one is human safety, next one is instrument safety, third one is environmental regulations. For example, if I am taking reactor in the chemical plant, the reactor must be operated at 100 pscg. Beyond that, if we are operating that reactor with some higher pressure, at that time the reactor may burst, and this may lead to some dangerous situations. For avoiding that one, we need to maintain the reactor with 100 pscg. pscg means pounds per square inch at gauge pressure. So, for maintaining the pressure at 100 pscg, we need to introduce some external intervention. That external intervention is nothing but your control system. Okay, control system means we are taking one reactor, the reactor present temperature the current reactor pressure will be measured with some pressure instruments. We are making the measurement of pressure in the reactor. Then that measured value will be compared with the desired set point value of the 100 psi GE. Then we could find the deviation or error occurred in the reactor. That error value is given as input to the controller. The controller will estimate the control action. The controller will estimate the control action, and the estimated control action will be implemented to the process, that reactor, through control valve. Through the control valve only we are admitting the pressure. Depends upon the current pressure, we need to increase the pressure or decrease the pressure. By the way of which you could maintain the pressure at 100 psi G. The next one is production specifications. Production specification means you are making some products in the industry. That product must have uniform quality as well as uniform quantities are desired. For maintaining the uniform quality as well as uniform quantity at the desired value, we need to introduce that external intervention. That external intervention is nothing but your control system. Next one is environmental requirements. There will be some state and federal laws which enforce to maintain. Here we need to follow some state and federal laws to maintain the concentration of chemicals in the effluent stream. Then sulfur dioxide concentration in the stream which is rejected to the atmosphere. The third one is wastewater which is returned to the river or lake. Here, for avoiding the pollution control, the state and federal laws are enforced to maintain certain level. The first one is to maintain the chemicals present in the effluent stream. We need to maintain the chemicals at a particular level. Next one is the sulfur dioxide concentration in the stream which is rejected to the atmosphere. It is very difficult to control the sulfur dioxide unless we are introducing the control system. We need to control the sulfur dioxide mixing in the atmosphere. We need to control the sulfur dioxide concentration in the atmosphere. The next one is wastewater which is returned to the river or lake. For that also external intervention, that control system is very essential one. Next I move on to the operational constraints. The plant have certain constraints inherent to the atmosphere. The first one is distillation column. These are the things involved in the chemical plant. Distillation column should not be flooded. Then if you are using tanks in the chemical plant, at that time the tank should not overflow or go dry. Third one is the temperature in the catalytic reactor should not exceed the upper limit. Suppose the temperature of the catalyte is increasing the upper limit, at that time it will change its characteristics. At that time it won't be useful in the process industry. For avoiding that one, we need to control the temperature of the catalytic. Then fifth one is economics. If you want to maximize the profit what you are getting from the plant, by the way of which you could reduce the cost. Reducing the cost and maximizing the profit is people are expecting generally. These are all about the requirements to meet the plant objective. To maintain all these requirements, there is some external intervention is required, and that external intervention is nothing but your control system. Next, I move on to the heart of the topic of issues and need for process control system. First, let me discuss about the issues. The first issue is the influence of external disturbances. Suppose you are using some temperature control process, you are heating tank system you are taking, there you are heating the process. At that time, for that device, the incoming liquid coming from some place, the outletting liquid leaving from the process. The incoming liquid coming to the process is this may disturb with so many causes. The pump is used for pumping that liquid. The pump may not work properly due to aging of components. Otherwise, due to ambient conditions, the incoming liquid temperature may be changed. Like that, so many cases will be there in the process industry. Because of that, some external disturbance variables disturbing the process. The process is in operation at that time, so many things like pump is not operating properly because of aging of components, then due to ambient condition change, like that so many things will be happening in the industries. These are all external disturbances occurred in the process industries. Then stability of a chemical process. Stability means the process when you are increasing the value, the process will be operating in a normal conditions. Then if you are disturbing the process because of some external disturbances, the process may get disturbed. After some time, the process must be come to steady state conditions. That one is nothing but your stable process or steady state process. Suppose the process is not reaching the steady state value and the value is deviating from the set value, set or desired value, at that time we can say that one is unstable process. Then this kind of things happening in the process industry. Next one is the performance of a chemical process. The performance of a chemical process also issues occurred in the process industry. For avoiding that one, we need to go for some things. What are the things we can see? The influence of external disturbances. The necessary things will be suppress the effect of disturbance on the output. Suppress the effect of disturbance. Disturbance is nothing but your load variable. You need to suppress the effect of disturbance. I mean that load variable on the output. Next one is we must ensure the stability of the system. The system is working with some inputs. Ensure that whether is system is working in the stable manner or not. That one is nothing but your ensure the stability of the system. The next one is optimize the performance of the system. Optimize is the correct value. In that way, if you are maintaining the input and output and what are the materials you are using, that all in a correct way, that time you can get the profitable output. That one is nothing but your optimize the performance of the system. Let's see one by one. First, I am taking the example of heating tank system. Okay, this one is the heating tank where incoming liquid coming with the flow rate of F suffix I and temperature of T suffix I. The outletting liquid leaving with the temperature of F and temperature of T. Here our objective is to control the temperature of the outletting liquid. So once you decide to control or maintain the temperature of the outletting liquid, the premost requirement is measurement. Since without measurement we couldn't control anything. So for making the measurement of temperature of this one, we need to use one temperature sensor. The temperature sensor may be thermocouple, RTD or thermistor. Depends upon the requirements. We need to use that particular temperature sensor for making the measurement of this temperature. After making the measurement of temperature of the liquid in the tank, the measured temperature value will be given to the summing point. For that summing point, we are giving the desired set point value. The measured value is compared with the set point value. At that time, what you are finding the value is error. Generally, error is given as input to the controller. According to that error, the controller will estimate the control action, and the estimated control action will be implemented to the process through control valve. Control valve is for final control element. Here, depends upon the nature of process, we need to use the various types of controllers. The controllers are, it may be proportional controller or proportional integral controller or proportional integral and derivative controller. Suppose if you are using single tank pressure control system, that time pressure P only controller is enough. Okay, suppose you just wanted to control the temperature process. So temperature process is generally slow process. At that time we need to use PID controller. Then some places we are using some PI controller for very fast process. Depends upon the nature of the process, we need to select the controller for effective control action taken. Okay, so according to that error, the controller will estimate the control action, and the estimated control action will be implemented to the process through control valve. Here f suffix st is nothing but your manipulator variable. Okay, here epsilon is nothing but your error. The error is nothing but your T set point. That one is given by the control engineer, and the measured temperature T suffix m. The measured value compared with the set point value, and it could find the error. According to that error, the controller will estimate the control action, and the estimated control action will be implemented to the process through control valve. We can represent this one in the form of block diagram. So this one is nothing but your process. So here I am writing the process. The process will be disturbed by some disturbance variable. Because of the disturbance variable or load variable, the process output value will be deviated from the desired value. That disturbance, that output value will be measuring with some measuring device. In this place, since this one is temperature transducer, since this one is temperature process, we need to use some temperature sensor. The temperature sensor may be thermocouple, RTD, thermistor. Then the measured temperature will be given to the summing point. There you are giving the set point value for the temperature. The measured value will be compared with the set point value, and it could find the error value. The error value is given as input to the controller. The controller is giving the control output. According to the control output, the final control element, I mean that control valve, estimated the control action, and it will vary the manipulator variable. That manipulator variable is nothing but your steam flow rate. According to the steam flow rate, the process temperature will be increased or decreased, depends upon the requirement. So here the process value will be getting disturbed by the incoming liquid temperature or incoming liquid flow rate. So because of the increment or decrement of this value of Fi and Ti, the process value will be getting disturbed, and due to intervention of the control system, we could avoid the error, and we could cope up the value, and the temperature of the outletting liquid will be maintained at the desired value. Next, I move on to the external disturbance. The same example I am taking. So let me still more detailing. I just wanted to give. So this one is for heating tank system. Through the spiral tube, I am admitting the steam. I just wanted to maintain the process at the desired temperature. The outletting liquid temperature value will be T. That value will be maintained at the desired temperature value of T suffix D. Then I can control the level of liquid in the tank H at the desired value of H suffix D. Let me startup procedure will be I am taking. After the startup procedure what I am following, this will reach the steady state. If there is no change of input variables. I mean that input variables are Fi, Ti and steam flow rate. These values and all not at all changing. Then the process remain at the steady state and there is no need of any control system. If the process inputs and all not at all changing, the output is also not changing at the steady state. At that time, no need for control system. But this is not the case in practice. Okay. Now I am taking the error value. The error value E is equal to desired temperature minus the measured temperature T. I am taking error is nothing but the desired temperature minus measured temperature. I am going to analyze this process with two things. First case is E is greater than 0. Second case is E error less than 0. First case I am taking E is greater than 0. Suppose error is greater than 0 means what it means? The temperature error is greater than 0 means error value is positive. I mean that TD will be, desired temperature value will be greater than the measured temperature value. Then we for desired temperature value equal to the measured temperature value, we need to increase the measured temperature value. For increasing the measured temperature value, here you need to admit the more amount of steam to the spiral tube. By the way of which only we could increase the temperature to the desired temperature value. We can increase the temperature of the liquid stored in the storage of liquid. Storage of liquid temperature value will be increased to the desired temperature value. For that, more amount of steam must be admitted. Suppose I am taking the case 2, the error value will be less than 0. Error value is less than 0 means this value will be negative. At that time, what will happen? The TD value will be less than the measured temperature value. At that time, the measured temperature value must be decreased. I mean that the storage of liquid temperature must be decreased. At that time, we need to reduce the steam flowing into the tank. This is the way we are opening or closing action will be doing by for increasing the steam or decreasing the steam, for maintaining the temperature of the outletting liquid at the desired value. This is all happening because of the external disturbance. Because of the external disturbance means variations in the Fi or variation in the Ti will disturb this outletting liquid temperature. That's why we are introducing the external intervention. By that external intervention, we could control the process. Next, I move on to the stability of the process. Here, I am taking some graphical analysis. I am going x-axis I am taking time, y-axis I am taking output. Generally, in y-axis we are taking the output. I mean that measured value. The output may be temperature or concentration or density or pressure or level or flow, whatever may be the physical quantity. That physical quantity value will be taken in the y-axis. X-axis I am taking time. With respect to time, the process response, how it is varying, that one only you could see in the response. Okay. Initially, the process output value will be at the steady state. Okay. Initially, the process value will be at the steady state. At particular time, t equal to t naught, the process get disturbed. At particular time, t equal to t naught, the process get disturbed. Okay. Then, if you are leaving the process as it is, the process after small oscillation, the process reaches the steady state by its own. That kind of process we can say stable process or self-regulating process. When x is disturbed at t equal to t naught, x returns to the, after small oscillations, x returns automatically to the steady state. That kind of process we can say stable process or self-regulating process. Here no need of external intervention. Next case 2 we are taking. Here also x-axis I am taking time, y-axis I am taking the output value. The output quantity is getting disturbed at a particular time of t equal to t naught x, where x does not return to the steady state. It will oscillate and the oscillations will be keep increasing. At that time we can say the given process is unstable process. That time only the external intervention, I mean that control system, is coming into picture to bring the system to the stable condition. In that point of time, we must remember that the first case, after small oscillation, it will come to the steady state by its own. So that's why we are saying this one is self-regulating or stable process. Sometimes it is not. I am not at all saying here no need for external intervention 100%, because this is for only one issue. There will be 3 issues are there. First one is external disturbance, second one is stability of the process, third one is the performance of the process. Here this process reaches the steady state. We are only talking about the stability. As far as stability is concerned, we need not go for external intervention. But other two issues may be coming into picture sometimes. At that time, we need to use the control system to bring the system to the steady state condition as soon as possible. Moreover, for avoiding the disturbance and to improve the performance of the process, for that reason why we need to introduce the control system. So, I am not saying 100% no need for external intervention. I mean that no need for control system. In this case, generally we do not use control system most of the cases, but few cases we need to introduce the control system for avoiding the external disturbances and improving the performance of the system. But this one is concerned, we must introduce the control system to bring the system to the stable condition, because this one is disturbed and the disturbance will be keep increasing. For reducing the disturbance and we must bring the output to the steady state condition, we need to introduce the external intervention, I mean that your control valve. Next issue is to optimize the performance of the process. To optimize the performance of the process, I need to use the example of continuous tilt tank reactor, I mean that CSTR. Continuous tilt tank reactor, CSTR. This one is the tank. Okay. We are admitting the reactor to the tank. Here this one is heating process is taking place. So enormous amount of heat will be generated. So the jacket of the wall of the tank, we are admitting the coolant. The coolant will be entering this side and go through the walls of the tank and it will leave in this side. At that time, at particular temperature, it will produce some products. Okay. Here, exothermic reaction is taking place. Here, the reactant A is producing the desired product and the undesired product. The reactant A produces the desired product and undesired product. Okay. How can we make the product this in the economical way? We need to increase the desired product. We need to maximize the desired product. And we need to minimize the undesired product. Then only you can get the maximum profit. The economic objective is maximize the profit pi is equal to integration of 0 to t f of b comma a comma c, where t is operational time, b is revenues from the sales of product, a is nothing but cost of reactant, C is nothing but your cost of coolant.